Welcome back to the Decentralized Application Development Crashcasts. I'm Sheila, and as always, I'm joined by my knowledgeable co-host, Victor. Before we dive in, I want to remind our listeners that your feedback means the world to us. If you're enjoying the show, please take a moment to rate us on your favorite podcast platform. It really helps us reach more developers like you. Today, we're continuing our journey through Season 2, focusing on core hole-punch technologies. We're in Chapter 2, exploring Hyperswarm networking, and specifically, we'll be diving into the fascinating world of DHTs in Hyperswarm. But first, let's start with a quiz question for our listeners. Victor, would you like to do the honors?
Absolutely, Sheila. Here's a brain teaser for our audience. In the context of P2P networks, what does DHT stand for, and what common problem does it solve? Take a moment to think about it, and we'll reveal the answer at the end of the episode.
Ooh, that's a good one, Victor. It really gets to the heart of what we'll be discussing today. Now, before we jump into the nitty-gritty of DHTs in Hyperswarm, could you give us a quick refresher on what DHT stands for and its basic concept?
Certainly, Sheila. DHT stands for Distributed Hash Table. It's a decentralized system for storing and retrieving key-value pairs across a network of nodes. Think of it as a giant distributed phone book that all the peers in a network can use to find each other and share information.
That's a great analogy, Victor. So, if I understand correctly, in the context of Hyperswarm, the DHT is used for peer discovery. Can you elaborate on how that works?
You're absolutely right, Sheila. In Hyperswarm, the DHT plays a crucial role in peer discovery. When a peer wants to join a particular swarm or topic, it uses the DHT to find other peers interested in the same topic. It's like leaving your contact information in a specific section of that giant phone book we mentioned, so others looking for the same topic can find you.
That makes sense. But I'm curious, how does Hyperswarm's implementation of DHT differ from traditional DHTs we might see in other P2P systems?
Great question, Sheila. Hyperswarm's DHT implementation has some unique features that set it apart. First, it uses a Kademlia-based DHT, which is known for its efficiency in lookup operations. However, Hyperswarm adds its own optimizations on top of this. One key difference is that Hyperswarm's DHT is designed to be more resilient to churn. That's the constant joining and leaving of peers in the network. It uses a technique called distributed sloppy hash table to improve reliability and reduce the impact of peers going offline.
Fascinating. Distributed sloppy hash table sounds intriguing. Can you break that down for us? It seems like it might be an important concept for our listeners to grasp.
Of course, a distributed sloppy hash table is a variation of a standard DHT that allows for some imprecision in the key value mapping. In practical terms, this means that instead of storing data at an exact location determined by its hash, it's stored in a general area. This sloppiness provides several benefits. It improves fault tolerance because if one node goes offline, the data it was responsible for is likely still available on nearby nodes. It also helps with load balancing and can reduce network traffic during high churn periods.
That's really clever. It reminds me of how in real life, if you can't find a specific book on a shelf in a library, you might still find related books nearby. Is that a fair analogy?
That's an excellent analogy, Sheila. It captures the essence of the concept very well. Just like in a library where related books are grouped together, in a sloppy hash table, related data is stored in proximity, making it more resilient to individual node failures.
Now, I can see how this approach would be beneficial, but are there any drawbacks or challenges to using a DHT in this way for peer discovery?
Absolutely, Sheila. While DHTs are powerful, they do come with some challenges. One of the main issues is the bootstrap problem. How does a new peer initially find others to join the network? Hyperswarm addresses this with bootstrap nodes, but it's still a point of centralization in an otherwise decentralized system. Another challenge is dealing with NATs, network address translators, and firewalls, which can make it difficult for peers to directly connect. Hyperswarm uses techniques like hole punching to overcome this, but it can still be a hurdle in some network configurations.
Those are important considerations. It seems like there's always a balance to strike in P2P systems between pure decentralization and practical concerns. Speaking of which, how does Hyperswarm's approach compare to other P2P discovery mechanisms you've encountered?
Great point, Sheila. Compared to other P2P discovery mechanisms, Hyperswarm's DHT-based approach offers a good balance of scalability and decentralization. For instance, some systems use centralized trackers for peer discovery, which is simpler but creates a single point of failure. Others use gossip protocols, which can be more resilient but may not scale as well for large networks. Hyperswarm's DHT approach allows it to scale to large networks while maintaining a high degree of decentralization. It's similar in some ways to how BitTorrent uses DHTs for trackerless torrents, but with optimizations specific to Hyperswarm's use case.
That's really helpful context, Victor. Now, for our listeners who might be thinking about implementing this in their own projects, do you have any best practices or tips for working with DHTs in Hyperswarm?
Absolutely, Sheila. Here are a few key tips. 1. Always provide multiple bootstrap nodes to improve reliability. 2. Be mindful of the data you're putting into the DHT. It's designed for peer discovery, not general data storage. 3. Implement proper error handling for network issues and peer disconnections. 4. Consider using Hyperswarm's built-in security features, like the ability to create private swarms. Remember, the DHT is just one part of Hyperswarm. It works best when used in conjunction with other Hyperswarm features for a robust P2P application.
Those are great tips, Victor. I think they'll be really helpful for our listeners. Now, before we wrap up, do you have any interesting facts or anecdotes about DHTs or their use in P2P systems?
Here's a fun fact. The concept of DHTs was first introduced in 2001, and within just a few years, it revolutionized P2P systems. The Kademlia DHT, which Hyperswarm's implementation is based on, was so effective that it's still widely used today, over 20 years later. It's a testament to the power of distributed systems and good algorithm design.
That is fascinating. It's amazing how some fundamental concepts in computer science can stand the test of time. Now, I think it's time to reveal the answer to our quiz question. Victor, would you like to do the honors?
Of course. The quiz question was, in the context of P2P networks, what does DHT stand for, and what common problem does it solve? The answer is, DHT stands for Distributed Hash Table, and it solves the problem of peer discovery in decentralized networks. It allows peers to find each other without relying on a central server, enabling scalable and robust P2P systems.
Excellent. To summarize today's episode, we've learned that 1. DHTs, or distributed hash tables, are used in Hyperswarm for efficient peer discovery. 2. Hyperswarm implements a sloppy DHT for improved resilience and load balancing. 3. While DHTs offer great scalability and decentralization, they come with challenges like the bootstrap problem and NAT traversal. 4. Proper implementation and use of Hyperswarm's features can help developers create robust P2P applications. Thank you all for tuning in to another episode of Decentralized Application Development Crashcasts. If you found this helpful, please visit crashcasts.com and consider joining our Discord community. Your support on Patreon helps us keep producing this content. Don't forget to subscribe and rate us on your favorite podcast platform. Until next time, happy coding.